All right, so in this video, we're continuing on the 1.1a notes page. We're going to go over the subsets of real numbers, and we'll briefly talk about the order of operations here, okay? So the first set of numbers, subset of real numbers we're going to talk about is the natural numbers, okay? It's also called the counting numbers. So when you learned how to count, you started with 1. So 1, 2, 3, 4, etc. So those are considered the natural numbers or the counting numbers, okay? So that set of numbers is made up of the following: 1, 2, 3, 4, 5. And then this 3 dots here is what we call an ellipsis, and that just means that pattern continues forever. So 6, 7, 8, 9, and on to infinity, okay? So that's the natural numbers. That's the first subset of real numbers we really want to talk about, okay? Now, whole numbers is all the natural numbers and then 0, okay? So whole numbers are going to be all the natural numbers or the counting numbers with a 0 starting it off, okay? So this set of numbers is made up of starting with 0 and then going 1, 2, 3, 4 on to infinity, okay? Integers is the set of all natural numbers, their opposites, and then we include 0 as part of the integers, okay? Notice there's no fractions in here that can't be simplified down to a whole number or its opposite, okay? So the set of all integers is made up of, note we start with an ellipsis, which means this pattern goes on to the left to negative infinity, okay? And it builds up like -5, -4, then -3, -2, -1, and we continue on to positive infinity, okay? So the integers is the set of all natural numbers, their opposites, and 0, okay? Rational numbers. And this is where sometimes it gets a little confusing between these two. Generally, natural numbers, whole numbers, and integers are pretty easy for people to remember. With rational numbers, okay, it's numbers that can be written as the ratio of integers, okay? And there's some examples given here. 1/3 is a rational number, okay? Square root of 25 is considered a rational number. If you simplify the square root of 25, you get 5. Well, 5 can be written as 5 over 1, or 10 over 2, or 15 over 3, and so on, okay? So because radical 25 can be written as the ratio of integers, it's considered rational, okay? And then -2/5, okay? -2 over +5, the ratio of 2 integers, okay? Now, one thing you can kind of use to help you here, if you write rational numbers in decimal form, the decimals are either going to terminate, okay, like 0.75, which stops there. That would be like 3 over 4 is 0.75, or repeat, okay? So 0.16 repeating, all right? Now if you want to look up here, 1/3 would be 0.3 repeating, so it repeats forever. Radical 25 terminates, it's 5.0, and -2/5 terminates, it's -0.4, okay? So those are rational numbers. Well, if rational numbers can be written as the ratio of integers, irrational numbers cannot, okay? Numbers that can't be written as the ratio of 2 integers, okay? There are some easy examples, okay? Any square root that's not a perfect square, like square root of 25, 25 is a perfect square, it simplifies to 5.0. Well, radical 2 does not. It's 1.414, and then there's a pattern that keeps on going forever, okay? Pi, we know, is 3.1415, and so on. Okay, there's no pattern here, okay? So it doesn't repeat, and it never terminates, okay? They've calculated pi out to more than 1 billion places, okay? And e is a number that we're going to deal with when we're solving exponential equations and working with logarithms, okay? And e is just like pi, okay? Never terminates, never repeats, or has a pattern, okay? So irrational numbers, we've got square roots, and then special numbers like pi and e, okay? State the order of operations. Quickly, I want to go through this. First off, I'm not going to use one of those, memory tools here. You guys, by this time, you should know the order of operations. Grouping symbols, not just parentheses. The more complicated math you get into brackets, you get into curly braces, and so on. So we want to call those grouping symbols, not just parentheses, okay? Next is any term that has exponents attached, all right? Then we do multiplication or division from left to right. And then we do addition and subtraction from left to right, okay? So that's the subset of all the real numbers, natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And then a quick overview of the order of operations.